a book, right? With all of our exponent rules. And so as we go over things today, I'm going to turn different places in the book, and you guys could too, because I told you could look at your book in your notes. By the way, I'm missing a glue stick. If anybody happened to take my glue stick yesterday, if you put it on my table, I won't get mad. But, coming back, it can be as you walk out of the room, I won't even be paying attention. I'm going to turn different places in the book, because couldn't this be a good thing to study? Yeah, I think so too. But, let's go ahead and look in the book for, guys, what property would be a good one, or what page would be a good one to look at for number 1 as to how this was supposed to work? Yeah, I would say the second page. Because the second page in your book, if I can pull up in the webcam real quick, showed the following. If it opens up. Go on, webcam. There we go. What does the second page say that we are supposed to do whenever we are, wait a minute, what's the problem? Multiplication problem, right? Okay. Whenever we have a multiplication problem, what are we supposed to do to the exponents? Now, wait a minute. But what happens to the base?
Stays the same.
Stays the same. So what was the mistake here? They changed the base. The adding is perfect. That's exactly what they were supposed to do. You multiply, you're supposed to add. But this should have just been 2. So the correct way of doing this would have been instead to do 2 to the 4 plus 5. So that's not right. What is right? Now some of you guys might have put that in your calculator, but that actually is exactly what I was looking for. 2 to the 9th power. Everybody good?
Yeah, we're good.
See? They put the 2 times 2 together, but the base is supposed to stay the same. It was just a 2.
Would it be wrong if you said parentheses?
Oh, around the 2?
Yeah.
Totally fine. Totally fine. Alright, number 2, guys. What rules do you think we should review real quickly about number 2? And maybe there's more than one.
When you're dividing.
Okay, when you're dividing, that's an important one. So let's go ahead and when you're dividing was the next page. So when you're dividing, what are you supposed to do with your powers?
Subtract.
Think of this as a big old subtraction sign. So when you divide, subtract. But wait, I heard someone say add, and I totally agree. That was super important for the example also, because the example didn't just have division. What else did it have?
Multiplication.
Okay, didn't just have division, but also had multiplication. So, technically, it's actually a PEMDAS kind of thing. We should have done the multiplication first, and then the division. In the sense of multiplication, was it okay for them to say x to the 5th times x cubed is x to the 8th? Is that good?
Yeah.
Because what do they do to the exponents? Good. Multiplying needs to add. But then what were they supposed to do? This is a big subtraction sign, not division. A big subtraction sign, not division. So what should this have been? Keep the base. 8 minus 4 is, I think some of you are telling me the answer, and I agree. X to the 4th. If you got at least one of them, give me a thumbs up. If you got both of them, keep it up. Questions? Questions, yeah.
On the first one, how do you know when to add the
Like
where,
this?
Yeah. Because on some of the problems you have to multiply.
Exactly. So wait. We were just reminded sometimes you add and sometimes you multiply. So let's go back to our book, yeah? It's this specific one right here. When do you multiply and when do you add? We add exponents when we're multiplying powers. We multiply exponents when we're raising power to powers. So if you have this parenthesis, and kind of actually, isn't that what algebra teaches you? When you have parentheses, something next to each other, don't you usually multiply it? So that's kind of a way of remembering too. But when you raise a power to a power, that's multiplication. And when you multiply, that's addition. And when you add, no. X squared plus x to the 5th, no. You can't do anything. Power to a power, yes. Multiply, yes. Divide, yes. Add. Does that make sense? And we can go to study too. Okay, so kiddos, I'm going to go ahead and open up. Don't worry, this isn't you. This is you. Do you guys see what I typed in to the answer presentation tool for our textbook? 1 through 32. What was that? That was homework number 1. You guys go find for me homework number 1. It's the one that I graded yesterday, right? 1 through 32. But hold on, what do I have after 1 through 32? As you're turning. 37 to 44, 48, 49, 70 to 72. You just can't see it. Isn't this homework number 2? Cool. Why do I have only the evens selected, even though all of them were homework? The odds are in the back. You can know whether or not you're wrong. Doesn't mean it shows you how to do it, but you can at least know whether or not you're wrong. Now, Trey, no, it's perfect, Isaiah, because when you're doing homework, shouldn't you go look and see if you're getting them right?
Yeah.
That's important. That's a good thing. Now, if you're just writing down answers, that's a bad thing. Which is why, as I walked around yesterday, didn't I tell some of you, I need to see some work? Right? So if I just saw answer, I'm not saying it's awful, because the evens, you can't just grab that from the back of the book. Now there are websites online where maybe you could have grabbed it. But if I'm just seeing answer, I don't see your process. I don't see how you did the problem. And if you have to mark it wrong in class, especially the evens, because you might not know the answers to those yet, I need you to be able to look at your work, or me to look at your work and be like, what did you do wrong? Oh, see, you did this here, and that wasn't what you were supposed to do. So you're supposed to be writing what the question is, and then showing me work, and then showing me the answer. So we're going to go ahead and grade the evens right now. Do you guys have a color pen now?
Yeah.
Why would I not want a pencil right now? It looks, yeah, so somebody could be doing this real fast and all the answers, which I wouldn't grade anyway for being 100% after I gave you a warning yesterday. But also, if we have a quiz tomorrow, and if it's on homework, theoretically, what are the problems that you should be studying the most, or trying over and over again the most? The ones you got wrong, but you won't know what they are unless your brain marks it with a color pen to say, ding, 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 watch out here, right? So, color pen is a good idea. You can ask your groups if you need one. Yeah.
On page 296, there was no 70.
Well, here's a good question. No, you're okay. Can I show you guys your book real quick? Whenever I do homework, and this is part of learning me as a teacher, learning who I am and how I work, right? Page 296 takes you to the beginning of which homework section, guys?
6.1.
Okay, so in my head, when I say page 296, I'm telling you, look for the exercises in this, or under this. Does that make sense? So I guess every night I could give you different pages based on where the problems fall. But can we all be in agreement that I'm going to give you the page for which section to go looking for whatever numbers? Is that okay? So yeah, thank you guys. I've had a couple of you be like, page 296 didn't have. I'm telling you what section to go under, and then 1 through 32, 37 to 44, just stay under this section. Is that cool? Okay. Because that way I figure it's a little bit easier just to remember one page number and then go to the problems that you need rather than me continually changing page numbers. I'm like, let's not do that. All right, guys. Let's go ahead and grade numbers 2 through 12. Let's grade numbers 2 through 12. If you got it wrong, it's okay. If you got it wrong, it's okay. Just go ahead and put a little slash through whatever answer you put. If, for instance, you got number 6 wrong, put a little slash through yours, and then write the right answer in your color pen. And in just a second, we're going to go over any questions you have on numbers 1 through 13.
It's 5 to 13.
Oh, it's 5. Thank you. I put 1, didn't I? Here, let's scroll down then. We'll start at number 6. Thanks, guys. I forgot that it was 5. Starting at number 6 then, through 18. Then we'll go over questions 5 through 19. there anybody who can't see the numbers? Do I need to zoom in? Are we okay? You can't see. Okay, kiddos. You've had a little bit of a chance to grade 6 through 16. Do we have any questions on 5 through 16 that you guys want me to go over? Andrew, what's up? Number 8. Anything else besides number 8? Yeah. Number 16. Anything else on 5 through 16? Yeah, Andrew. And number 12. Okay. So let's go ahead and transition there. If for any reason you haven't been able to grade these ones, you can look on one of your group members. But I'm going to go ahead and transition over to number 8 and 12 and 16. Sometimes I might get you guys up to the boards, but since we're grading 2 homeworks at once and we have a quiz tomorrow, I'm just going to kind of do it from here if you guys don't mind, a short, sweet version. And if you want your exponent rule book, you can open up your notes. That way you can be looking at why I'm doing what I'm doing. So in number 8, we have the expression -2 to the -5. Whenever we see a negative exponent, this is a thing, right? We cross the line and change the sign of the exponent. So we could think of this as over 1. Where's that -2 going?
Down low.
Good. And we change the sign of the exponent. Now what happens if this guy just disappears? What's on top now? Got him. So technically you could kind of just box this and be done. But if you look at the answer from the answer key, what did they do? They went one step further. How'd they get 32?
They solved it.
Yeah, they actually solved it. What they did was, this is 1 over negative. And the negative's on the outside, which is kind of weird. It actually ends up kind of coming all the way out. But 2 times 2 times 2 times 2 times 2. It was actually kind of like that. And if you threw that in your calculator, that ends up being -32. And -32 means the whole number is one big ol' negative.
So we need to get that.
Yeah. Well, to be able to match it with the back of the book. But do you see how I boxed this one? For the quiz, I love this answer. I think it's great. So either one would have been fine. Yeah, kiddo.
If 5 was positive, then we would have just like kept it.
Yeah, you would have just kept it. Okay, the next question that we have is number 12, meaning it wouldn't have switched position. Does that make sense? Cool. Okay. Number 12 gives us, it's in a new section. Oh, no, it's not. It's the very end of the section. -8 to the -2 all over 3 to the -4. Now, guys, I just noticed something. I totally ignored these parentheses. Did anybody realize that? I did not write my parentheses. That was my bad. So actually, this was a little bit illegal. Do you know what would have been rewritten 5 times? Not +2, but -2. That was my bad. I apologize. But all those negatives, some of them pair up to be positives, and then there's one little negative left over, which is why the whole number was a negative. Now, in this one, who needs to cross the line? Both of them, because this guy, he has a negative exponent, so the -8 needs to cross the line and change the sign of his exponents. And what does this guy need to do? Yep, but in crossing the line, he goes up, change the sign of the exponent. If you had your calculator, you could have gone ahead and done 3 times 3. Now, some of you mental mathers, you're a little bit better with numbers than others. Maybe you would have gotten 9 times 9 is 81. Others of you, I'm okay if you use your calculator for these sorts of things. And then -8 times -8. We should know that one though, right? +64. But if we check out that answer, oh, if it was possible to reduce, they would have reduced it. So therefore, you know what? You were totally good. But guys, if I don't let you use your calculator tomorrow in the quiz, guess what I would have been fine with you leaving? This answer. Because that means you're showing me you know how the exponents work. And that would save time on the quiz too. I might not make you evaluate and go all the way. Does that kind of make sense?
Yes.
Cool. Number 16, we have 15. C to the -8, D to the 0. What's your favorite part of this one as far as simplifying?
1.
Yeah, anything to the 0 power is just 1. We could put a little times if that's helpful. So we end up with 15 times c to the negative 8. The 1, anything times 1 stays the same. Who needs to cross the line? Which one?
Negative 8.
But who's to the negative 8? The c and the 15 or just the c?
Both of them.
Do you remember from our book from yesterday?
No, you did.
What power is 15 raised to if nothing's there?
No, you leave.
Good. So the 15 stays. The c crosses the line, changes the sign of his exponent. A few of you guys were making mistakes in our game yesterday. In the sense of, if there's nothing there, put a 1. He doesn't change. He doesn't cross. Only the c does. Okay? Final answer. Good so far?
Yeah.
Okay. We're going to keep on grading the evens, so let's go ahead and move on down to 18 through 28. And we'll go over questions 17 to 28. So go ahead and grade a few more. This is right near the end of homework number 1. All right, what's wrong? Yeah, if you guys missed any problems when you were doing it, you definitely want to get them down now because it might be a quiz problem tomorrow, right? As you guys are grading, if you come across a question, go ahead and raise your hand and let me know. We're looking for questions 17 to 28. Any ones that you don't understand or maybe you got wrong. It's a little warm. I'm going to open the door. I'm looking for questions 17 through 28. They can be odds, they can be evens. If you didn't grade your odds from the back of the book, you might want to go look at that if you have a little bit of extra time, because if you got one of those wrong, you want to go before tomorrow too. Any questions that we're coming up against? Andrew?
22 and 24.
22 and 24? I have space for another couple. Anything else? Yeah. 28? Anything else? Yeah. 22. Yeah. 20. Okay, we have a few questions, so I'm going to go ahead and start working on questions. So finish up whatever checking, whatever grading you're doing, all right? All right, number 20. Number 20 gives us P. Now we're dealing with variables, so we're simplifying, not just evaluating. 7 to the negative 2, Q to the negative 9. Now, I don't have any division. I don't need to do any subtracting because none of these bases match. P and 7 and Q are all different. But what is wrong with all of these? Oh, negative 9? Thank you, thank you. That's why it's really helpful for you guys to write down. One of the reasons to write down the problem. Okay, no common bases though, so we can't combine with the subtraction property, the division property, but we can cross the line and change the sign of their exponents, because doesn't P to the negative 8, doesn't P have to cross the line with his 8th power? Doesn't 7 squared have to cross the line? And what else has to cross the line? Q to the positive 9th. Remember, when you cross the line, you change the sign of the exponent. Now, could you go one step further and say, I know 7 squared is 49? Yeah, totally cool. But tomorrow in the quiz, I would take either version. This one or this one. Is that cool?
Yeah.
Okay. Number 22 gets a little bit crazier. There's a lot more going on. There's a 13. There's an x to a negative 5. There's a y to a 0. There's 5 to the negative 3. And z to the negative 10. Is there anything that we can simplify? Any bases that are similar or something that I can replace with another answer right now?
Yes.
Yeah, what's anything to the 0 power?
1.
Just 1, right? I put a little 1 in parentheses so I remember it's times, but anything times 1 is itself. So I can just actually get rid of him. But don't I have some guys in the wrong place? Now hold on. Who's fine where he is? 13, because if there's no power, I apologize, no exponent, what's understood? So put the 1 and tell yourself to leave him there. The 13 does not move. But doesn't everybody else have to cross the line? So x to the 5th will go down. What's going to be in my numerator, guys? 5 to the power of 3. What should I put in between so I don't get confused?
1.
A parenthesis or maybe a 1. I was just thinking like a multiplication sign, but either way. But what else needs to be in that numerator? Z to the 10th. Now there are no like bases. If you had your calculator, you could go ahead and do 13 times 5 times 5 times 5, but if you guys are okay stopping, I'm okay stopping. Andrew, did you have a question?
I was going to say, does it matter if I do 10
Well, we usually put the numbers first, just like that's algebra. We put the coefficient and then the variables. But I don't care which number goes first, as long as they're both up there. Is that cool? Okay. Number 24. Now it's time to get out that exponent rule book again. Because what's true about the bases of the numerator and the denominator, guys? They're the same. So, with division, we pretend this guy is a huge old subtraction sign. We're subtracting the exponents, 8 minus 5. But my question is, who's my base? It stays the same. Perfect. So your final answer would be -6 raised to what power? If you had your calculator, we could go ahead and solve for that, but otherwise we could stop just there, and that's fine. Yeah? One more, number 28. Gives us x to the -5. Now there's a few different ways of doing this. Yesterday during the game, I think 2 different people got it right, but they had 2 different ways of doing it. And Jonathan, this was kind of like your question, yeah? What's the property, guys? If you're just looking for properties, you're like, hey, it's a parenthesis. This is a power to a power. What do we do with the exponents? Yeah, multiply them. So we could just go straight to multiplying -5 times 3. -5 times 3 is? 15. But guys, why can't we stop? I've been stopping early in a lot of problems, but why can't we on this one? It's a negative. And what do negative exponents tell me? Cross the line, change the sign. What line? Well, can't anything be over 1? So cross the line, x to the 15th goes down, and when there's nobody left, what's always understood?
1.
Got him. Sorry, that's not under the light. There you go. All right, that gets us up through 28. Let's finish off homework number 1, which means we need to grade up to 32. As people are grading up through 32, I'm going to let you might have to change to homework number 2. You can keep on grading. We're going to take questions from the very end, 29 through 32 of homework 1, and then we're starting in on homework 2. Did I miss someone's question? I heard someone say, oh. Okay. Tonight's back to school night, so I might not be here like all the way up until the event, but at least if you guys ever come in, I can always give you a whiteboard and say, hey, let's try some problems. Give you a little baby quiz and see how you do. I think you guys have had time to grade 30 and 32. Can we pause real quick and finish homework 1? Is that okay?
Yeah.
Okay. Are there any questions on 30 and 32? 29, 30, 31? Oh, we're okay? Oh, yeah. 30. Okay, we're going to homework 2. Anything else on homework 1? On 29, 30, 31, 32, are we okay? Okay, so let's switch to homework 2. Let's switch to homework 2. Let me let you guys go ahead and finish grading homework 2, then we'll go over any questions on homework 2 that you have. You can kind of see 38 through 72, the evens that were there. But Alexis, you said 32, right?
Yeah.
Okay. If you come up against one, just raise your hand. Let me know if you have a question. Anything on homework 2? $49? Good. 49. Oh, that was a hard one, yeah. It might sound still on my phone. I apologize, guys. It's a horrible example, isn't it? Levi, I wanted to let you know that you might want to grade your homework because now we're into the homework you can. If you want to grade it, it's up on the board. I have a question on 32, a question on 49. Anything else you guys want to see from homework 2 that you got stuck on? Yeah, Alexis. 38? 48. Thank you. Yeah, that was a hard one. And 70. Andrew?
72, 42.
Okay. All right, if we have more time, we can do more questions, but let's start with these ones, especially 48, 49, because they were kind of beastly. All right, number 32. Gave us, hey, isn't this a lot like, are you guys looking at the problem? It's a lot like the opener, yeah? It's not? But not the first one, the second one. Isn't it a lot like the second opener?
Yes.
Okay, so we have two different rules. We have a multiplication rule and a division rule. What do you guys think, order of operations, what do you guys think we should do first? Yeah, Kayla. We are going to use the z. I'm not sure I would subtract first, though, just because that might get confusing.
Wouldn't you add the exponents first?
Yeah. Can we try that?
Yeah.
Can we try? Because the adding, aren't they kind of next to each other, ready to go?
Yeah.
And then this one's going to be removing.
Yeah.
Yeah. I think it'd be a little easier for our brains to subtract if we add first. So think about multiplication, division, PEMDAS. You do whatever comes first. So this one comes first, a multiplication. And why do I keep saying adding? Yeah, because we need to. Whenever multiplying like bases, we need to add the exponent. So it's going to be z to the 10. And then, Kayla, now I think it's the easiest time to do what you said, which was subtracting, because this division, right, is one big subtraction. What's my final power of z going to be? 10 minus 5, which is 5. Is that cool? Number 42 goes over in like another part of the book. But we're still using whatever rules are in that exponent book we made yesterday. We have negative 5 times p cubed, all cubed. What's the big word we need to remember whenever we see multiple things raised to a power?
Multiplication.
Yeah, we're going to be doing power to power multiply, right? Kind of what Jonathan was asking earlier. We are going to be multiplying, but wait, before we ever do that, what do we need to be careful of? Distribute. The distributive property. Because this negative 5 right now has no exponent. What's his understood exponent? 1. But what's it going to become when we distribute the power? 1 times 3, it's going to be negative 5 to the 3. And then what's the p cubed going to also be? To the 3. So we need to bring this cubed into both pieces. And now let's simplify. Power to a power, what do we do? Multiply. Good. So it's going to be p to the power of 9. And then if you don't have your calculator, I'm okay with you leaving this negative 5 to the 3. But some of you might already have either memorized or you did use your calculator and you got all the way to negative 125. But tomorrow I would take either one. Because we probably won't take time. I won't let you have calculators tomorrow because I'll let you stop early. Okay? We have number 48 and number 49, which I knew they were tricky. There were 4 problems. I only gave you 2 in there because I knew they were kind of rough. Number 48 has a lot going on, so let me go ahead and write that down and we'll get back to it. So it's 4s to the 5 to the 5th power, t to the negative 7th, all over negative 2, s to the negative 2, t to the 4, all raised to the 3rd. All right, it's kind of a beast, yeah? We do need to distribute this guy. But do you guys realize some of these bases are the same? what can we do with, think of PEMDAS. We're in the parentheses trying to simplify before dealing with outside the parentheses. Is there anything we can do with these T's or these S's to put them together? Yeah, it's quotient, right? And quotient we subtract. So what if I write now the 4 over the negative 2. I'm just going to kind of, those are numbers. I'm going to put those off to the side. But can't I do S to the 5 minus negative 2? Don't I have to subtract 5 and negative 2? What am I going to do with the T? Subtract, yeah, negative 7 minus 4. And then what's still going on outside all these parentheses?
3.
Yeah. Now some of you could actually do this in your head. 5 minus negative 2. Oh, that's just going to be, careful, 5 minus a negative 2. Doesn't that switch to plus? So it'd be S to the 7th. What's negative 7 take away 4 for the T? Negative 11. And then that's all raised to the 3rd power. So then we could finish this off by first doing the division. Guys, what's 4 divided by negative 2? Negative 2. It's going to be raised to the 3rd power. S to the 7th is going to be raised to the 3rd power. How do we do a power to a power? Multiply. So S to the 21. And then T power to a power. What's negative 3 times 3? Or sorry, negative 11 times 3. Negative 33. The last thing we'd have to have T cross the line, change the sign, and everything else gets to stay. Now this is probably a scary problem because some of you, even just this subtraction was really hard, like 5 minus a negative 2, negative 7 minus 4. There were lots of places to make mistakes. This is one way of going about number 48. There actually is another way though, and some of you might like that way more. Can I show you the other way? We could have gone in the parentheses and we could have done something else instead. We could have actually said, who needs to change positions before putting the like bases together? Did anybody need to cross the line, guys? If we ignore this stuff, if we start over again, did anybody need to cross the line? Yeah, this guy, T to the negative 7. So wouldn't he have gone down? And doesn't S to the negative 2 also need to cross the line and go up? So what if I rewrote this saying, okay, 4 is to the 1, so he stays, negative 2 is to the 1. S to the 5 was fine, but T to the negative 7 had to come down. T to the 4 got to stay, and S to the negative 2 had to come up. Is this easier on anyone's brain than all this subtraction stuff? Some of you might like the subtraction stuff better. Good, you can go that way, you'll get to the right answer. But some of you are like, I think I like that better because now what do we get to do with the like bases? Not subtract, just add. And just add. And we would end up with 4s to the 7 over negative 2t to the 11. You would have still had to do 4 over negative 2 is negative 2, but then you could have raised everybody to the 3rd power. And you would have gotten, once you did power to power multiply, to the exact same answer. To the exact same answer. Guys, I am recording this, so if at any point you are like, man, I know there was that really hard problem, I'm not even going to show you number 49 because he was really hard like 48, and I promise you number 49 will not be on the quiz tomorrow, so you can kind of ignore him if you want. We'll just go through one of the really hard ones, number 48. You can go through and watch the video tonight, and then you can walk through and figure out which way your brain likes better, the first way or the second way. But then we had a couple people with questions on 70 and 72. The nice thing is that's from section, actually, that's kind of like from section 6.2. 70 was square root of 25. 72 was plus or minus square root of 1 over 64. I was looking to see if you guys remembered how to square root things.
Yeah.
And fractions are even a little bit harder because you have to square root the top and the bottom, distribute the square root, which the square root of 1 is 1, square root of 64 is 8. But guys, these are also problems that wouldn't be on the quiz tomorrow because this isn't what we've been learning. It was introducing the next section. So I need to come back here and do something about the quiz because we haven't even started 6.2, right?
Yeah.
So what's the quiz going to be on?
6.1.
Only the homework that we've done this week, which is homework number 1, homework number 2, and the worksheet, which you guys already know the right answers to because the worksheet was they have honeycombs. So what's your homework tonight?
Study.
Just study. Now hold on, pause. I need to tell you guys one thing that we haven't talked about yet this year. When you study math, hold on, pause. I know the bell's going to ring. I need you to hear me out. When you study math, you can't just look at a problem and be like, I'll remember tomorrow. You need to get a blank piece of paper or a whiteboard, write down the problem, hide the answer, try it. You can't share the answer and expect it to know what to do because tomorrow on the quiz you're going to know the answers. Not necessarily. It's going to be a blank problem. So give yourself a blank problem tonight to work on. Retry the homework is my best advice. Bye, guys. If you have questions, come by me.
I'm not going to make tacos and then put them on a stick.
I didn't really know where to put the words, so I kind of just...
No, that's perfect. That's perfect. I just love being able to see. Oh my gosh, Sean's real fast. This works. Okay, good. And I'll check number 2 tomorrow.
Okay.
Yeah, you're welcome.